about 1.6 divisions times 2. So the difference between them is 1.6 divisions times 2. Milliseconds. That's the difference between them. Now if I divide that by the period of either one, they're both going up and down with the same frequency of 60 hertz. So if I go divide that by the period of both, I would have to now put this the period is about, it's the difference between here and here, so it's about 1, 2, 3, 4, 5, 6, 7, 8, about 8.6 divisions. So 8.6 divisions times 2 milliseconds per division. So it's basically 19.2 milliseconds. So that gives you the difference between them divided by their period. So that's 3.2 over 19.2 times 2 pi to make it into radians. That's the experimental way of calculating the phase angle between two waves. Okay? The difference between them divided by the period of either one divided by, this is 17.2, right? I mean, we really don't even have to multiply by the 2 milliseconds, you know. So we get this one is the phase angle in rads. If we want to do it in degrees, then we would multiply by 360. So this one's going to be about 1/6, and this is about 6. So it's going to come out about something like 1 rad. So I think it's working out, which is we have 1 rad, you see. What is it? 1.17 rads. And the reason it's negative is because graphically you can see the sources behind the sources behind the voltage of the resistor. Now to make it more accurate, what I would do is go to a more detailed one. So I was on this scale now. I would go to a smaller scale, and then again I would try to freeze it. And now maybe I could do it on this scale. Now it's perfect. So it's 0.6 divided by 3.4. 0.6 divided by 3.4 times 2 pi. Is that better? 0.6 divided by 3.4? 1.1. Okay, so we're getting a little bit more than the theoretical. Okay? Now what I want to do is put a variable frequency function generator, because now all this time we've been stuck with we couldn't change our frequency, right? So now comes the big guy. This guy can change the frequency, can change the amplitude. So just replace the power supply by this and turn it on and change the frequency as Is that freeze mode there? Change the freeze, change this. If it's not working, then we might want to switch these. Okay, so I could change the frequency here, make it anything I want. Right now it's 42 hertz, 261 hertz. It's going to change the amplitude. So this is the voltage of the resistor. This is voltage of the source. So they're pretty much similar at this point. So what do we want to test out? Let's make it, let's test out the resonant frequency. At the resonant frequency, they should be the same, right? Now you see both of them. If I change the frequency, okay, so if let me use the XY mode. If I go change the frequency, what should the resonant frequency be? Put that all in. At that frequency, they should resonate together, and the voltage source and the resistance source, they should be exactly the same. $3,000. 3,481 hertz. Okay, so let me go to 3,000. Okay, and if I go like this on dual mode, it should be a straight line. Now if I go to the regular, not the XY mode, but if I go like to this mode, they should overlap and be exactly the same wave. You see? So if I go to the same vertical scale, they should always resemble each other at that frequency. You see, same wave. Okay? But if I change the frequency,